I'm Aaron Mulder. I'm going to be talking about building real-time web applications. A little bit about me. I'm the CTO of Chariot Solutions. Aside from putting on this conference, Chariot's a software development, software consulting shop. Before this morning, I might have said we work with all the technologies you're learning about today. After that talk, I really can't say that anymore. But we work with a lot of the technologies we're talking about today. Other than my work, I have been or am a contributor to a lot of open source projects, JBoss, Geronimo, Camel, ActiveMQ, the Postgres JDBC drivers. If you see something all of these things have in common, it's that they're not JavaScript. If you had to work with a JavaScript framework I wrote, I think you would not consider it to be one of the good parts. So why am I giving this talk today? You're not going to hear about kind of the background motivations and drivers of all these different projects. You're going to hear about how we use them all together to build applications that meet customer needs. So that's what I'm here to talk about today. So what do I mean by real-time web applications? Something where something changes and you want the web page to update immediately. You don't want it to update 5 seconds later. You don't want it to update on a periodic basis. You want to update immediately when new data is available. So traditionally we'd talk about a stock ticker or something like that. These days it should be a social networking feed. But in reality, the kind of applications we see are collaboration apps, perhaps games. In this case that I'll be talking about today, it's a monitoring console that one of our customers was looking for. So why are we here? Why are we talking about this today? One of the reasons is there's new push technology. In the old days, you would just reload the page, maybe put it on a timer or something like that. That was not very good. So then we went to Ajax Polling, where at least you could do that in the background and only reload fragments of the page, but it's still not real time. So then we went to Ajax long polling and some techniques like that. That's okay. That gives you a more responsive page, but it has some downsides too. You've got these connections that are constantly opening and closing, and we can do better than that. So today, I'll be talking mainly about WebSockets for pushing data from the server to the browser. But as well, there are some alternatives, CometD and Socket.io, that we'll talk about. Now, aside from that, there are some great new JavaScript frameworks. I mean, giving this talk 5 years ago, I don't know what I would have been talking about as far as JavaScript frameworks go. And that would have been really frightening, like I said, if I had to write this all. There are dynamic charting libraries, more good JavaScript libraries. And then we have a background tasks API, so you can have your logic running in the background without sort of blocking the rendering thread in the browser. So a lot of these technologies kind of come together and help us build more responsive real-time web applications. But why am I actually giving a talk about this? I mean, you could Google these things. The good news is there are a lot of libraries out there, and you can make them work together. The bad news is it's not that easy. You have to struggle a little. The documentation is kind of limited. A lot of the examples are very tightly focused in one direction or another, and it's not always easy to figure out how you would use it in a real situation. So what I'll be talking about today is a real-time monitoring application. One of our customers had several servers deployed in different clusters and different applications running on each one, and they wanted a live real-time monitoring tool that would say, this is the load on this cluster, and you could drill down and say which customer is causing the load. It would give you alerts, turn things red and stuff like that. I've obviously simplified it to fit in slideware, but we'll talk about an application of this nature. So the first thing I'm going to start with is Backbone.js. Who here is familiar with Backbone? And who went to the Ember talk yesterday? OK, good. So you're probably pretty familiar with this. One of the things with Backbone is you can use it many different ways. And that was one of the reasons Ember came about, to kind of resolve that. But in spirit, Backbone is model view controller for JavaScript. You put your data in the models, and the web page is a view or a composition of views. So you change the models, the page updates. The views update. You can fire events. You can have controllers. You cannot have controllers. That's one of the things with Backbone. It's kind of wishy-washy. You can use it in different ways again. That's part of the issue with it, I guess. You look at some documentation, and this one has a controller, this one has a router, this one just has a view and a model. But at the end of the day, we're just trying to get stuff done here. So I'll talk about the approach we used for this application, but there are others. Now, in particular, one of the things I'm not really going to go into is using templates to generate the HTML, because it just would have cluttered up the slides a bit more. But you can certainly do that. The ways I'm going to talk about are just directly manipulating the DOM, and there are several different approaches even for that. Again, I'm going to talk about one way you can get this to work, and there are many others out there. So what we really need out of Backbone is a place to store the data, a set of models. We want to update when the models change. So as new data comes in from the server, we put it into our models, the view updates, and you get that real-time effect on the screen in the browser. And then we need a way to gather that data from the server. So polling works out of the box. There's no effort at all. But I'm going to talk about WebSockets and some other options as well. So the very first goal, you'll see I'm also not a graphic designer, one of the many things I'm not. I was sitting in that keynote yesterday thinking about his big list of things that he is, and I can give you a big list of things that I'm not. But this is basically what we're looking for. We're looking for a monitoring system. It shows several different nodes in our cluster. It shows the cumulative number of requests they've received over time, and the breakdown of the response time for each of those requests. So node 1, 38%, we got a really good response time. 7%, we got a really bad response time. And then the instantaneous CPU usage on each node. And this is kind of phony data for purposes of the talk, but it gives you an idea of the kind of things we're looking at. So starting with the HTML, we have kind of your typical header block importing a bunch of libraries, Backbone, and then it needs underscore. We're using jQuery. This is the charting library I'll talk about later. And then the realtime.js is my JavaScript that we're going to go through as we talk about this. And there's a very little style sheet there as well. So the starting point of this, I'm just going to put in a bunch of static HTML. There's going to be a table of data. There's going to be an ID on each cell in that table. So I can go in and put in the data I want by overwriting the contents of a particular cell based on its ID. So I start with a Backbone model. This really could be virtually an empty slide, but just to fill it up, I have some default data there. You don't even really need that. But I create a model that extends the basic Backbone model. Then, because I have one of those for each server we're monitoring, I have a collection, a Backbone collection that I call the monitor data list. It has a list of those monitor data objects we created on the last slide. It has a URL that it knows to fetch data from. And then importantly, I'm sticking an instance of this list of monitoring data into a global variable called data. And you'll see here and there that we refer back to that. So when I want to update the page, I create a Backbone view. It's called monitor item view. And it's binding to the change event on the model a call to the render function, which is right here. So when the model changes, we call this render function. And what that's doing, as you can see, is it's looking up cells in the table by their ID, and it's putting in a value that it got out of the model. So it's pretty straightforward. Again, not using templates or anything. I'm just looking for those cells popping in the data I want. And then I have a view for the whole application. And so the previous view was for one row in the table. This is for the whole thing. So it binds to the reset operation on that global data variable, our collection of data. So anytime that collection of data changes, we are going to create new row views. And then we're going to render the row views on the bottom line there. So we have this sequence where we change the data for the whole list. We create a new set of row views, and each of those row views renders, and it pops in the data into each of the cells. So is this the most efficient way you could possibly do things? Not really, but we'll go through a couple iterations here. And finally, just to make sure this all works, I'm going to start with a polling loop. Polling is something we want to get away from, but it's the easiest way to make sure this is functional. So I do a set interval, and I call data.fetch. Because I gave the model a URL, it knows where to fetch from, and my backend is just returning JSON. So again, just started with polling because it's the easiest way to make sure everything's working, and then we can move on to the better techniques. But before we do move on, let's talk about polling for a second. Is it scalable? Well, on the one hand, you have a lot of overhead of opening and closing connections, right? Your web browser is, every time it wants new data, opens a new connection to the server, gets the data, closes it, and then comes back a little later and does the same thing, and again, and again, and again, and again. But on the other hand, at any given moment you look at the server, there are not a lot of open connections. So, if you have a huge number of clients, your server doesn't need to support a huge number of simultaneous network connections. Maybe that could be good, or maybe that could be bad. I guess it depends on what that overhead is. We'll talk about that a little more at the end. But actually, let me show the demo. It's going to start the server in the background, and then the demo is not working. Goody. There we go. OK, so this is our demo. It's connecting to the server on a polling basis. Every time it polls, it's popping in all these cell values. It's basically doing what we want, but not in the most ideal way. Among other things, we're creating all those new views every time we poll. That's not very efficient. So there's some room for improvement here. Okay. So now I'm going to talk about WebSockets, the better way to get the data pushed from the server into the client. I'm going to have a brief digression into long polling. So this is comment, this is continuations, techniques like that. I don't have a demo for this or code for this. But the idea here is you start an Ajax request to the server, and you just kind of leave it hanging there until the server has some data for you, whereupon it returns that data to you. And then you open a new connection to the server and just leave it hanging there. So the advantage is, as opposed to polling, you get the data right when the server has it ready for you, because there's always a connection there waiting on data from the server, and the moment it gets them, it can return it to you. The downside is you're still doing that recycling of opening and closing your connections all the time. So it is more responsive than polling. You get the data more instantaneously when the server gets it, but you're sort of abusing this whole process, opening and closing and leaving these connections open a really long time. So it's kind of the worst of both worlds. You've got a lot of simultaneous connections to the server, and you also have the overhead of opening and closing them. So this is what we're trying to get away from. So with WebSockets, this was part of HTML5. You can open a connection that's a persistent connection to the server. You can leave it open as long as you want. You can send data in both directions. In this case, we're only receiving data from the server, but you could, in theory, be sending data as well. And it doesn't interfere with your normal Ajax requests. So you could have sort of command operations going back and forth to the server in Ajax requests, even to the same resource. The server side can distinguish a request coming in, even if it's to the same URL, whether it's a WebSocket connection or a normal HTTP connection. So you can use this in conjunction with your normal Ajax techniques. In this case, we're just going to be using it to get a feed of the real-time data. So one of the wrinkles with WebSockets is the browser support. It's as part of HTML5, it's only in some of the most recent browsers. And furthermore, within Firefox, it's only in the really most recent browsers, except the older ones used a different name for it. So like up through Firefox 3, there was nothing. And then in like 4 through 8 or 9, it was called MOZ WebSocket. And then in like 10 and 11, it's just WebSocket, which is the official standard name. So we have this kind of weird code at the top just to find the right name of the object to create. And then we create it, and the URL you use looks just like the HTTP URL you would use, except it's WS : instead of HTTP : And if you want a secure WebSocket, it's WSS instead of HTTPS. So it's a very similar URL. And again, this same resource could be taking Ajax requests as well. And what we've done here is attach a message listener function to that WebSocket. So when data comes in, our onMessage function is invoked. And all we're going to do, assuming that's a bunch of JSON data coming in, we're going to parse it as JSON and pop it into that global data model. So there's not a lot of code here, and it makes a big difference in terms of the network connectivity. Now on the back end, again, since I'm a Java guy, I have a servlet here that's running in Jetty. All that servlet is doing is when it detects a WebSocket connection, it's putting it in an array or a set here of connection handlers, and then when it has new data to push out, it just goes through all the connection handlers in that set and pushes the data onto them. I'm not going into a lot of detail on the back end here. So what does WebSockets look like? The front end is going to look pretty similar. Just going to get the back end started. All right, that stopped when I shut down the old one. There we go again. So now we're looking at it using WebSockets, and the only way you can really tell that is by looking at the JavaScript code. The effect is the same, but now we only have one connection to the server. We don't have that constant polling, opening and closing sort of behavior. So this is better as long as you've got a browser that supports WebSockets. You can avoid a lot of that overhead. Back to the slides. So there was not a lot of code there. I just replaced that little polling loop with a couple of lines to open the socket and attach a handler to it. The star there is because, again, the browser support is an issue. IE6, forget about it. This is coming in IE10, actually. Even you have to be on a pretty new Firefox to get the right object name there. So, if you can use this, it's great. But there are some issues too. If you look around on the web for the advantages and disadvantages of WebSockets, you'll start to see some things like proxies. If proxies don't support WebSockets, you can have problems. Connection timeouts. There's no way to establish for your code to know what a connection timeout is, so how often it ought to be trying to recycle a WebSocket connection. There's no way for the WebSocket itself to handle that appropriately. Then, if a client is disconnected and comes back, they don't see any messages that were sent while they were gone. So, it's this persistent connection, but if, someone's on their phone and it, is roaming and switching between Wi-Fi and 3G or something like that, they're just going to miss stuff. There's no support for like multiple channels over the same connection. You can't have, it's not like a message queuing system where you would have different topics and queues or something like that. Instead, you just have one pipe, and it's up to you what you put over that pipe. There's no control channel. You can't send a ping to see if the server's there. You can't ask, does anyone have a lower timeout than 30 seconds on the pathway between me and the server? So, are these disadvantages or not? I guess it depends on what you're looking for. So what are the alternatives? If you don't have that browser support, or if you don't like those disadvantages I was just talking about, there's the Comet-D approach that uses the Bayeux protocol. There's socket.io. Honestly, if you Google for WebSockets, it'll take you about 5 seconds to find a blog that says, WebSockets is okay, but the browsers don't support it, so check out socket.io. So you go to socket.io thinking, oh, it's this neat thing. And what do you see like on their front page? We can use WebSockets. And you're like, wow. So I could just use that. And if WebSockets are there, it'll use them. And if they're not, it won't. And then, great. But it's all a lie. Both of these, both Comet-D and socket.io, proudly say we can use WebSockets, but they're not just an abstraction around WebSockets. They are a protocol that requires a backend, a specific backend, and a specific JavaScript library. And yes, they can use WebSockets under the covers, but it's not like there's something that just abstracts away WebSockets versus long polling. They are a front end and a back end and a message format and a whole package. So you can adopt that whole package if you want to, if you like what it's giving you. But it's not just sort of something that abstracts away whether you're using WebSockets or long polling. It's more than that. So for instance, socket.io is built on a Node.js backend, and you can find maybe a Java backend but it's not so easy and it may not be well supported. If you're looking for a Ruby backend, I have no idea. So these are not really drop-in replacements. They are really kind of completely separate technical alternatives. So you may look at those if you say, we really need wider browser support, or we'd really like to have a more message queuing sort of system where missed messages can be delivered and where we can have multiple channels over this one connection. Certainly you can look at those things. But it is really a different animal than WebSockets. So how do you make this decision? Obviously, the browser support is critical. For this particular application we're talking about, the client said, we'll use whatever browser you tell us to, because it's just our people monitoring the system. We're not putting this on the internet. So that would make a difference, obviously. One of the questions, again, is do you want a pipe like WebSockets? It just gives you a pipe. Or do you want a messaging protocol like Socket.io or like Comet.d? What backend runtimes can you use? Do you feel like you need to really write portable code, that you can move from one server or browser to another? All these questions. But one way or another, you can find a good solution here. So the next thing I'm going to talk about is charting. We want to put some charts on this real-time monitoring console, and let me just skip ahead to this is what it should look like now in my brilliant graphic design skills. We have our same old grid on the bottom, and we now have a chart on the top, and the idea is you can click a cell in the grid and it'll start graphing the value of that cell over time. And again, that should all be updating in real time and so on and so forth. So there are some great JavaScript libraries out there that are very easy to incorporate, and we can use them with Backbone. We just put the data in a Backbone model. We put the chart rendering in a Backbone view. There you go. So setting up a chart, this is in the Backbone model. What we're doing is just adding an array of chart data points. So we'll track 50 points. And then we set up the chart. What it's going to do is we've added a new div to the HTML page called chart with the ID chart. So you just tell the charting library which div it ought to render into, give it some options, and give it its data set. Off it goes. And then what we need to do is set up our view so that as the data changes, we actually chart something. So what we're going to do in our model is have fields for basically which cell we're charting, which server are we interested in, which data field in that row are we interested in, and then every time we get new data, and this render function is called, what we're going to do is slide all the data points over one, add the new data point to the end, and then tell the chart to re-render itself. So again, what we're looking for is we click a cell on the table, it charts that view. So we've got to have some kind of event listeners on the cells that you could click. And then we need to be able to have a view associated with that table row so that it can set up those listeners. And when you look at what I did before, where I laid out all the table in HTML, and then I was just poking values into different cells, it doesn't really work well with this approach. There's not a good way to put event listeners on the cells and to associate the views with the cells. So instead, we're gonna change the HTML a little bit. So it's going to have a table with no rows when it first comes up. So here's the div that the chart's going to go into. Here's the same table header block that was there before. But instead of any rows, we just have this empty T body and with the ID data table. And that's what we're going to populate our rows into as part of the view. So here's the view. This is the view for the application. And we're telling it the element we care about is the element with the ID data table. We're going to have this rows array that holds the views for each row when we set them up. And then again, we're binding to the reset element, the reset event on the model, and we're calling the new data function that we'll look at on the next slide. So what that new data function does is it's either going to, if there are row views that it's created already, it's just going to put the model data into those. Otherwise, it's going to use the new row function here to create a new view for each row that it needs to have. And that one is going to add the view to our array and render it onto the page. So the first time you load the page, it's going to render a bunch of new rows into the table, and then every time after that, it's just going to push new data to the model for those rows, and that will cause the data to be updated. And this way, it turns out to be pretty easy to set up the event listeners. So this is just the render function for the row view. It renders into a TR tag, and this is where you'd obviously use a template or something like that rather than just a big string concatenation. But this is my slide where, so it sets up a bunch of TDs with particular classes and then calls update row, which is what's going to be called every time the data changes. We've bound to the change event on that model a call to this update row, and it's just, again, looking for the cell with a particular class name and then putting in a value it got out of the model. But this time we're not recreating the same views every time new data comes in. This time we're using the same fixed set of views. We're just giving them new model data to re-render themselves with. So it's a little more efficient as well. And the event setup becomes very easy. All we have to do is say, if you click something with a request class, we should call the click request method. If you click on something with a CPU class, we call the click CPU method. And this is just a sample in one of those. And all this is doing is basically storing which row and which field we care about, so that in the render event for the app, it can update the data for the chart. Okay. I'm going to start the back end for that one. Try this again. Okay. All right, so here we go. So I don't know if you noticed, but if you look here, when the page first comes up, there are no rows. And then as soon as it gets the first set of data, the rows pop in. And if I click one of these, then it starts charting it. So this is the behavior we're looking for. You can click, I click the CPU cell here. So as the data is coming in, our chart's updating. We've got the same basic behavior as before with the table. Now, because each of those rows was rendered based on server-side data, we got slightly better machine names because we can read the IDs coming from the back end. So it's a little minor improvements, but the main thing is we have this real-time graph on top of our real-time data. Okay. So the next thing I'm going to add on top of that is web workers, where you can use background tasks, background threads. So the desired behavior here is we want to color the fields on the screen depending on whether they're over or under some particular threshold. So just for this example, we'll color the CPU red or green depending on whether it's over the average CPU that we've observed so far for that node. And we want that calculation to happen in the background thread so it's not locking up the UI rendering thread in our browser. Now, this is a very trivial calculation, but it's easy to imagine a case where you have some more complex calculation, and you don't want the user to be dragging their screen and it's not painting, or trying to switch tabs and it's not working because you've locked the browser UI thread doing some fancy calculation. And on top of that, since your cell phone has 4 cores now anyway, you might as well take advantage of that. So web workers is another HTML5 standard, and it's going to let us do this. What we're again looking for is just here some to colorize these cells. Otherwise, it's pretty much the same as before. Web workers are portable, assuming again you have a very modern browser, IE 10 or a pretty darn new Firefox or Chrome. They are scripts that run in a separate thread. So we have a JavaScript script. It's going to run in a completely separate thread than the rendering thread, and it does not have access to the DOM for thread safety. You wouldn't want that, putting things in the DOM at the same moment your main thread is handling some event and putting things into the DOM. You could really make a mess of that. So it just can't see the DOM at all. And instead, what it's going to do is communicate with the main thread using events. So it's going to do a bunch of calculations and then pass something back to the main thread, and the main thread is going to then update the DOM. And that's how you manipulate the data visible to the user. Now, as an additional thread safety measure, the data passed back and forth between the main thread and the worker is serialized. So you end up copying it rather than having two threads referring literally to the same object instances or something like that. Which makes it very easy to kind of ignore a lot of threading issues, but also means you've got to be a little careful about how much data you're throwing back and forth. So if you want to create and call a web worker, it's very simple. It's the top couple of lines here. So we create a new web worker. We tell it what script it ought to be operating off of, and then we attach a message handler function to it. So when the worker passes the main thread some data, this is what it's going to do. In this case, it's just going to take that data and stuff it into that global model. So we've updated our WebSocket code here, and instead of parsing JSON and putting it in the model, it's just going to throw that data over to the worker thread. We even let the worker thread do the JSON parsing, and then what this worker thread is going to do is it's going to do some calculation of whether the CPU usage is good or bad. It's going to assign a class. It's going to assign a new model variable called CPU class, which is either going to be good CPU or bad CPU. So we just add an extra line to our rendering code to apply that class to the right cell in the table. But let's look at the code for the worker thread. This can look different ways. If your worker thread is just going to start and do something, it can just have a script that does something. In this case, it's going to start and wait for data to be passed to it. So the main thread is listening on that WebSocket. And when it gets data from the WebSocket, it's going to pass it to the thread. So this thread has a function it assigns to onMessage. So this is what gets called when data is passed from the main thread to the worker. So again, it just parses that data as JSON, and then it's going to march through each row, calculate the average CPU usage, check whether the current CPU usage is above or below that, and put either good CPU or bad CPU into this new CPU class property. And then when it's done with all the rows, it's going to post that back to the main thread. So the onMessage function is the one that receives data from the main thread, and the post message is the function we use to send data back to the main thread. So again, if we look at these two slides together, the socket gets some data, it posts the message to the worker processes the data, posts the message back to the main thread, and then the main thread receives it from the worker and sticks it into the model. And then the view renders and applies that class. So some things to note about this web worker script. There's no window object anymore. You can't use a window object to access the DOM or to create a WebSocket or to use an XML HTTP request or something like that. Instead, there is a global object. It's just a different one, and it still has functions like set timeout, WebSocket, XML HTTP request, except that some of the browsers have some bugs. So for instance, in Firefox, the XML HTTP request is there, but the WebSocket isn't, even though the documentation says it should be. So you can have workers that spawn other workers, except there's a bug in Chrome, and that doesn't really work. So this is life on the bleeding edge. The one thing that really is, I guess, a concern is that serialization in or out. Browser bugs aside and whatever, you have to be conscientious of the data you're passing back and forth. So in this example I gave, the main thread received data, it passed it to the worker processed it and passed it back. So we have this chunk of data getting serialized twice every time this happens. So let's go a little further. Instead, let's take the WebSocket out of the main thread and put it into the background thread. So all the main JavaScript is doing now is setting up the web worker and saying go. And then that web worker, instead of having an onMessage function that receives data from the main thread, it's going to create the WebSocket, as long as you're not on Firefox. And then it's going to put its logic in a onMessage handler on that WebSocket instead. So this way, we have the WebSocket data coming directly to the background thread. The background thread processes it, and we only serialize it once when we post it back to the main thread to update the UI. So this is an improvement. Again, the main issue here is going to be the browser support. So we'll do the demo of that. Okay. And now you can see down here, we have the colorizing coming in. The average is about 14 or 15. So any values under that come in as green. Any values over that come in as red. The charting's working as before. But this calculation for this is done on the background thread. And you can have much more extensive calculations done in those background threads. But this basically covers the requirements that the customer was looking for in this case. We want to see server monitoring data in real time. We want to be able to colorize it or indicate when things are going out of bounds. We want to see graphs. So we've essentially achieved what we set out to do. We're relying on the fact that they were willing to commit to a modern browser. But that being the case, it's a pretty nice set of technologies. We're encapsulating data nicely in those backbone models. It's not a bad solution. So, do you guys want me to run through the code for everything quickly? Just like go through it so you can see it all, or yeah, okay. Make this smaller. You can really tell I'm a Java guy here. I've got my IntelliJ open. The main HTML file is again not very interesting. It has the header and not much else in it. This is the main JavaScript function for the main JavaScript document for the main thread. It has the backbone, models, and views. So at the top there, we've got our data item model. We've got our data list collection. We've got the global variable right there. We've got the item view. It has the event handlers. It has the logic to render the row the first time it's created and to update the row every time new model data comes in. We're putting in the values here. We're putting in that CSS class there. These two functions are just to handle the clicks and to indicate on the to indicate how the graph should be set up. This is the view for the application level view. So it's got the data table that we're populating things into. It's got the logic for setting up the chart right here. So we're setting up a bunch of empty values. We're setting some options on the chart. Like this is one that turning off the shadows makes it render faster in real time, stuff like that. We've got the logic for when we create the new rows. The first time we get data and we don't have any rows in the table, we've got the logic for creating those rows. We have the logic for when we get new data from the server, we're going to either create the new rows or populate the models for the existing rows. The render function at the application level is just setting up the chart. So it's again shifting everything over one position, putting in the new value, and then updating the chart on the screen. And then at the bottom here, we just have we're setting up the worker, we're setting up the WebSocket, and we have our message handler. So the WebSocket, this is the Firefox compatible version. So we have the WebSocket logic here. Though again, if you don't need to use Firefox, you can move that to the worker. But we set up the worker. We set up its message handler to update the data. We set up the WebSocket. We set its message handler to post the message to the worker, and then the worker script. That's the non-Firefox version on the bottom there. But this is the Firefox compatible version up there. So it receives a message from the main thread, does all the processing, puts in the right CSS class and posts the message back. So there's not a lot of code here. It's a small HTML file, kind of a middle and main JavaScript file, and this web worker file is quite small as well. The CSS is nothing special. Just has the CPU colors, red and green. So, again, it's, one of the nice things about Backbone is if you look at that main class, you're really dividing the logic into models and views pretty effectively. I have no controllers, so we can argue about whether that's good or not. But that's the code. So one of the questions that I really don't have an answer for is when is this the right technique to use? I mean, I mentioned a couple of scenarios where this could be good, where if you have real-time chat, some kind of real-time data feed, like monitoring data, social network data, whatever, a collaboration app, something like that. We could probably think of some more. But I don't really have an answer for what's the threshold where you stop polling and you start going to something like WebSockets. I don't know. If you have 5 users, then that's not a lot of load. If you have 5 million users, then maybe you can't have so many simultaneous open connections, or maybe you just need more servers to support that many simultaneous open connections. Doesn't matter how frequently the updates are coming. If you're only getting updates every 10 seconds, then you don't need a real-time connection. You could poll every 2 seconds, and it would be pretty prompt. Doesn't matter the overhead of opening and closing all those network connections versus the amount of data you're sending. If you're sending big documents, that may overwhelm the overhead of the connection opening. If you're just sending a little tiny bit of data each time, maybe the connection opening and closing is a significant amount of your effort. So these are questions I don't really have answers for. I'd be interested in what kind of applications you guys are thinking about when we talk about this sort of stuff, and whether you think some of these approaches are good or maybe not necessary or whatever. But that's the material I had prepared. So again, I'm happy to take questions, or we can have a discussion about some of the stuff that was on that last slide. These slides will be posted online. You can feel free to email me or talk to me. I'll be around for the rest of the conference.